Hello everyone, welcome to the next webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen. Today's webinar will be presented by Joel Alsop, who has worked in 12D model support and sales for Extra Dimension Solutions, our 12D model distributor for New South Wales, ACT and South Australia, for over 6 years. Prior to that, he had 20 years of experience in engineering with a variety of organisations within New South Wales. As there are now quite a few resources covering how to write snippets in 12D model, for today's session we're doing something a bit different. Snippets Under the Hood takes a high-level look at how and why things work the way they do, and also how to understand those error messages. This is a fairly informal session with the trainers from ExDS and 12D Solutions, but we invite you behind the scenes to hear about this incredibly useful aspect of 12D model. This is perfect for intermediate to advanced users. Over to you, Joel.
Alright, kick it off. We're not really going to run through and create a snippet because we've done that so many times and there's a training course now that'll teach you how to do that. So we just sort of thought I'd run through and we'll just look under the hood a bit and go through the snippets that we actually create in the training course and just kind of explain a little bit more what's going on them and what all the different parts actually do. So we'll quickly run through parameters and preprocessors, but then we'll look at formulas and do a bit more on variables. And something I did in the last training, which everyone found really useful, was debugging snippets, going through error messages and things like that and actually understanding what's going on with them. So we'll do a bit of that at the end. So parameters, basically, I think as most of you sort of know by now, they fall into two types. We've got user parameters, which is what you will actually see on the panel, which is for the user input, the user interaction, and then they've got auto parameters, which have no user input at all. They just work in the background and they're just actual code in the snippet itself. So you can see here, user parameters, we get choices, we get reals, integers, text, we can select models, strings, they can be optional, and there's a few different ones in there. Basically, there's all the information the user puts in when they insert the snippet. The auto parameters are sort of, like I said, hidden from the user. They'll pick up things like reference and hinge string name, start and end modes, project attributes. That's the one Pete and Paul, a lot of their payment stuff is just pulling in all project attributes in the background. And the other ones are sort of left and right suffixes and prefixes and the 0 and the I for the MX style naming. And it just does all that in the background so the user doesn't have to think about what's going on here. So this one down here, the auto LR, will just basically stick an L or an R on the end of the string name based on left side or right side. There's obviously start chainage, end chainage, and this one on the end is for absolute and extra start, extra end. So it's just, it tidies up the snippet and it just, like I said, just makes it easier. The user doesn't have to do anything with those. The preprocessors are the sort of programmy stuff in snippets. It's all the if statements and defining tokens in the background and sort of building flow control in, so the snippets don't have to be linear. They can actually loop back around on themselves. They can jump from one part of the snippet down to the bottom of the snippet, that type of thing. You'll see later we use a lot of this preprocessor stuff for error checking. The MTF errors are usually a bit flaky sometimes. They're very programmy speak and a bit hard to understand, so we're actually able to build error checking into the snippets and put a message to the user which the user can actually understand what the hell's going on rather than some weird pass error type of thing. Preprocessors are often, they can be as simple as setting a string color. So we're basically here, you look here, we've got a parameter called bike lane width. If the user puts a value in there, then this statement up here, so if val bike, so it's saying if there's a value for bike lane width, then set the color to pavement green. And I'm also defining another token here. This is what I'm talking about doing error checking. If the user leaves that blank, so else, just define the color as asphalt. So very simple, but it's just building simple logic into the snippets so we can handle things. And they're often used with these optional parameters because you don't have to put a value in there, but if the user puts a value in there, we need to do something. So this whole statement, this if, else, end, is just checking, has the user put something in that field? Yes, they have, we'll do something. Likewise with the shoulder parking width, has the user put a value in for the shoulder? If there's a value in there, so yes, there's a value in there, we're going to use this link name here. Else, if they haven't put a value in there, we're going to name the string a different name. So very simple statements like that just helps put a bit of logic in there, and otherwise we wouldn't be able to do these sorts of things. As I said, add logics and use for error checking. This one here is doing some error checking. So again, similar type of thing. This is from an RMS snippet where we can have a sealed shoulder and an unsealed shoulder, and when you have a combination, you can have a sealed shoulder or unsealed, or you can have sealed plus unsealed. So I'm checking whether they're putting a value here. Have they put a value for sealed shoulder? Yes, then I'm defining this token. No, then I'm defining this token. Have they put a value for an unsealed shoulder? Yes, then I'll define this token. No, I'm defining this token. And then what that actually does, I take these values here now, and then I actually come down here and check which values actually exist. So, and this is the error checking. So I'm actually checking here, okay, he's said I want to put an unsealed shoulder in, but he hasn't defined a sealed shoulder. Now you can't have an unsealed shoulder with a sealed shoulder without a sealed shoulder. And so rather than the MTF throwing up some random message, string not found, value missing or whatever, it'll actually put up this nice user message here that says RMS rule MTF snippet, please add a value for shoulder in there. You've selected unsealed shoulder. So that's kind of the sort of error checking that we're doing in the background, just to help users and make the snippets more user friendly so they can understand. And you'll see in some of the snippets, often a lot of these pre-processors will take up about 3/4 of the snippet, and there might only be half a dozen modifiers at the end that actually do the work. So these really are the sort of the brains of the snippet. They actually form the bulk of the work in creating these snippets. And then I'm defining, again, defining another token, which is then used later on. I said form the brains. Choice parameters are the other one that they need to control. So like I've got there, the optional ones are usually quite simple. With choice parameters, when you have a choice box, there's different values that the user can select from. In the back end of the snippet, we've got to define what to do with each of those individual values. So you can see here, each one of these drop-down lists, each choice, so speed, grade correction, and direction, each has its own set of statements to define what happens. So if I select 50 kilometers an hour, I need to define a length of 40. If they select 60, I'll define a length of 55, and so on and so on. So every value in that list has to be defined in here to tell the snippet what to do when the user selects it. And again, they can be as simple as, okay, selected 50, I just define a deceleration length of 40. In something like where we're going forwards or backwards, you've actually got a bit more to define, and you've got to start reversing everything and all that, so it's much longer. But again, at the end of the day, all it's doing is just defining all these tokens based on what the user actually selects. And again, this snippet here, it's getting up to quite a few lines, and at the end of it, there's 5 actual modifiers that do the work, but there's 80 lines of this pre-processor stuff. So it's the guts of the snippet. It's what does all the work. So moving on, formulas and snippets. Again, they'd be sort of pretty useless if we couldn't do just basic mathematics. So we started off with being able to just add values together, get a couple of widths and add them together, or multiply a cross 4 by something. But again, this is all moved on to, we've got sine, cos, tan, log, every sort of mathematical type of thing you can think of. We can get absolute values and all that type of thing. The key is the formulas can get complicated. It's a bit like doing formulas in Excel. Trying to write really large Excel formulas are a pain in the ass, and it's easier to break them down into smaller formulas, calculate chunks, and then sort of use all those values at the end. So we've got a simple one here. We've got our parking bay. The insert point for the snippet is this start change 0. To calculate the actual start of the parking bay, the absolute start of the parking bay is quite simple. It's just 0 minus this taper length, which is fairly straightforward. To get this end point up here, it's a little bit more complicated because we've got the end bays, which are a different length to the intermediate bays. So we need 2 end bays plus however many intermediate bays we've got plus the taper. But again, breaking that down into smaller formulas makes life easier. So we know we've got 2 end bays, so we just, the length of the end bays times 2 gives us a value. We then take that value, pass it down into another formula to calculate the total length of the parking bays. So we've got length of the end bays plus the length of the intermediate bays times however many bays we've got. And again, we take that value, pass that down and add on the taper, and then we've got the actual total length that we need to get our end chainage. If you were to do it as a single formula, end up with something like that. And to be honest, so many opening closing brackets in there, I actually took about three goes to get that right for it actually to run. So I personally find it much easier. It's more typing, but I find it much easier to be able to break things down into smaller chunks and then just start adding it together at the end. Snippet variables. So we're getting into a bit more heavier stuff. I think it was one comment Tony asked was, what's the difference between a variable and a parameter? Parameters are basically fairly static. The user sets a parameter or you use an auto parameter. When you hit recalc on the MTF, those parameters are set and they maintain that value for the whole recalc. Variables are a bit more dynamic. They started out a lot like what used to be the old copy command, which got changed to modify from link, where you can copy the width, height and crossfall of one link and apply those values to another link. And that's a fairly dynamic value because obviously the width of a road can change, the crossfall can change with super elevation, all that type of thing. So that's probably the easiest way to describe a variable, is it operates quite similar to that modify from link command, except that variables can do a lot more. Apart from width, height and crossfall, we can get the grade, the relative offset, so it's the relative offset from the previous link. We can get the absolute offset, which is the absolute offset from the reference string. Absolute height, level, x coordinates, centerline chainage, direction, tin heights, name, grades, and again the list goes on and on and on. Like I said, snippets, variables versus parameters. The parameters are set at the start. The variables are dynamic. They will change value as the MTF runs. As I said, classic example is width and crossfall will change. And we'll see that when we sort of jump in. We've got the car parking example. We'll see where the variables are working. The way variables work, we declare the link that we want to capture and assign an alias to it. So we're basically here we're saying we want to capture the edgeline link and we want to give it the name variable lane. We also want to capture the lip of curb and we're going to give it a name variable shoulder. So the blue is the actual link that the MTF is creating, and the variable name, the alias name, sorry, is just a temporary alias that we give to it that's used inside the snippet. It's not used anywhere else. These variables, by the way, are a snippet-only thing. You cannot do any of this straight in the MTF. It can only be done in the snippet itself. Like the modify from link variables, the main thing to keep in mind is you need to capture the value before you modify a link. So if you were to say, if you wanted to capture the lip of curb, the width of the lipper curve, if you capture that, if you modify the lipper curve and then capture the value, you'll be capturing the modified value. If you capture the value before you modify it, then it retains the original value. So let's say your lane width is 3.5 meters wide. If you capture that value as 3.5, it'll remain as 3.5, even if you go and modify that string later on. You'll still have that value captured as 3.5. If you were to modify it halfway down the road from 3.5 to 5 meters, and you capture the value after you've modified it, then you will actually have different values. It'll be 3.5 meters where it's 3.5 meters, but then when it widens out to 5 meters, the value of your variable will be 5 meters. So it's a little thing you got to be, it's all very dependent on the order that you capture things. And the good part about it is that you can capture a value and sort of store it to use it later, so that when you modify strings and all that, you can actually reuse the original value to pull everything sort of back in line type of thing. So there's a few snippets that are doing that, especially the ones that are sort of, you know, modifying lane widths and curbs and all that type of thing, where we got to do something like put in a parking bay and we want to insert a new edge line between the road and the parking bay. So what we do is you capture the width of the road before you modify the parking bay. So you've got the width of the road, so you've got the width that you want to put your edge line in. That kind of makes sense in a roundabout way. So this is how you capture it. So we say variable, we give the variable a name. So we got three sort of names going on here. We've got the original link name, we've got the alias name. Now we're creating the variable, and the variable is getting the width of that alias, which comes back to the width of the string. Variables can be used in different ways. You can substitute them directly into a modifier. So we're inserting a string here. So like I said, this string here, we've captured the width of the lipper curve, and we're actually going to use that same width when we insert our edge string. Or you can use them with other things. So you can actually, again, do a bit of formulas and basic math when capturing them. So I can define a token here with a width, the value of 2.6. I can create a new variable, width full, and I can actually add all this together. So I can get the width of the curb lip, I can get the width of the edge line, and I can add on that, you know, that token that I've created there. So it's not sort of confined type of thing, it's quite flexible. Again, you know, you can simplify that a bit again. So what we could do is we could capture the width of the edge line first, then we can create our new variable width full here, and we can just pass that variable down into here, and then get the width of the curb lip and then add on that one. So quite flexible in that regard. So what we'll do before we move on to this debugging stuff, we'll jump across to 12D. So this is our road snippet. You can see here we've got our parameters up the top. So we're just asking the user for, you know, lane width, the crossfall, and here's our shoulder width, which is optional. So to make it optional, we literally, you just put optional after it instead of a default value. And it follows the same thing as everything else in 12D. When it's optional, it's grayed out and in italic, so we don't have to put a value in there. Here we've got a choice box. It's a simple one. It's just got two types of curves, but you'll see here, if I click on that, it just comes down and it's in the list. It's very simple to add another one. I put Fred in here. Reopen that. And we've now got an extra one down there. Now if I try to run that, it'll break because I'm not telling the snippet what to do if somebody selects Fred. So you can see down here with these choices, I've got barrier and mountable. What I would need to do is literally copy that, put another one in here and call it Fred, and then tell 12D what to do if somebody selects Fred. So that's all being controlled like that. It's quite simple to edit. You just edit it, save the file, reopen the snippet, and it's there. You don't have to, you know, run anything or compile anything, that type of thing. It's all just, you can edit on the fly. Check him out while I think of it. And then moving down, once you've sort of done all this, you've defined, so there I'm, you know, defining colors as well, like I showed before. And then you've got just your standard. These here are literally just standard modifiers. You can see the small exception here, we've got shoulders. So if someone puts a value in for shoulder, then it's actually going to insert the shoulder. If there's no value for shoulder, what it will actually do is just skip over those modifiers. It'll say, I've got no value for shoulder, I'm not going to do any of that, I'm just going to go down to the end and then just carry on with life and do the rest of the road. So quite a simple little one. I'm just putting in a road, it's just got some choice and that type of thing. The other one we didn't touch on here was this display. This is a sort of a special one here. Anything you put in here, display, and then one of these names, it actually shows the values up in the modifiers themselves. So rather than having to open the snippet, you can actually see what values you've selected and go, okay, I've got a lane width of 3.5, I've got a barrier curb, and I put my footpath width in as 1.8. And these displays, you can have all of them in there or just a select few, just depends on how much information you want to send back to the user. In our parking snippet, it's a little bit more complicated. But what we're doing in here, if get this organized. You can see here in our perspective view, we've got some fairly hefty super elevation going around the corner. And so what we're doing that, if we were to insert the parking bay along here, then we had two options. We could ask the user to put in a crossfall, we could have a static crossfall just locked into the snippet. It's going to be a bit of a pain because it's not going to it's not going to match the crossfall going around the road, around that curve. This is where our variables come in, because what we can do, we can say, okay, we want to capture KL link. So I'm going to capture KL, I've given it its alias name. And then coming around that corner, because it might, super elevation, so our crossfall is changing and potentially the width is changing. There might be widening or something like that. So what I'm actually doing here is I'm capturing the width and the crossfall of the lipper curb. And then from that, I can actually pass those two values down so that when I insert my new edge line for the parking bay, it'll pick up the instantaneous crossfall at each cross section and the width as well. So if we turn this on and run it, you can see that as we come around the corner, come around the curve, the crossfall in the parking bay is matching the crossfall on the road. And like I said, any widening around there, this edge line here would also be matching the widening. Now, what I was mentioning before about capturing the values before modifying the curb, so you can see here I'm capturing the values of the lipper curb before I do any modifying. So that way I've got my width of lipper curb here so that I can insert that edge line at the exact same width that the lipper curb used to be, and then I can push the lipper curb out. If I'd captured these values after modifying the lipper curb, then you would actually see my edge line would be floating out here somewhere, and then the lipper curb would be out here to be all completely messed up. So that's where you sometimes you want to capture it after, sometimes you need to capture it before, but that's just a little trick where it's capturing the values before you modify something. So you're sort of storing that value in memory and you can use it later on. The other things in here, these pre-processors up here, they don't always have to be an if statement. We can simply define a token. And again, a lot of the snippets we've got in the library, we're defining these up the top so that we can just use these values later on. And they're easy, came up with that because it's easy for the users to edit, especially something like an end bay. So we saw the formulas before, the end bays being used down here and intermediate bays and all that. Rather than having the values buried down in these formulas where they're used multiple times, it's much easier just to define it once up the top. So if I want to change that taper length, I've only got to change it up here and then rerun the snippet, and that value passes down to wherever the word taper is used. So it's quite a simple example here, but some of the other ones, these values might be used 4, 5, 6 times throughout the snippet. But we define all that up front, makes life easier, we put it near the top, and away you go. The other one we got up here is info. Anything up here, so the double slash with info, this actually appears down in, if we open the snippet, we've got this little info button down here, so that actually all that information pops up in there. So again, it's all about getting information back to the user. We've got the display here for the values they've selected, but it's there, yeah, just to give a little bit of information to the user on how to actually use the snippet. They look at it and go, okay, I've got a bunch of values here which are optional. Which ones do I need to combine with what? Click on the info button and you'll see them there. Again, the library ones have got, some of them have got quite long help in there on what you need to do on some of the bigger snippets. Debugging, like I said, this is something that I chucked into the last training that I did, and the guys actually found it really useful because error messages are a fact of life. Understanding them is always the hardest part. So a lot of debugging stuff. So again, simple one, info, as I just showed you. That should actually say info button, not help button. But it just gives a bit of information to the user on how to use a snippet. They might put it in, it's not running. Let's go read the info and see what I'm doing wrong. And it's just basically that type of thing. Printing to the output window when you run a snippet. You can send messages to the output window. I showed earlier on in a slide where we're doing some error checking and then we're sending messages to the output window for the user. So again, it's good to send messages to the user so they understand what's going on, and it's also good for debugging because you can send values out to when you're writing a snippet, you can print the values to the output window, and when it's a formula it won't print the end result of the formula, but it'll actually print out the resolved values for that formula. So you get 6 plus 2 times 3, whatever, so it'll actually show the formula. So it's good in that way. When you're writing a snippet, you can actually see what values 12D the MTF is using to actually run the snippet. There you go, capturing user errors. So yeah, like I said, we're adding in error checking and putting custom messages out to the user that they can understand a bit easier than some of the stuff that 12D kind of spits out, which can be a bit cryptic. So we're going to run. I've got a snippet which, not surprisingly, I've just called broken. Pop that up for a sec. Snippet, and I'll grab broken. And straight away, error messages are coming up. I'm going to be jumping back and forth a little bit with PowerPoint here. So straight away we insert it, and this sort of error message comes up, and we get people ring up and going, oh, I got errors with my snippet, and they send it through and it's pass, error, this, that, blah, blah, blah. Really, it's giving you all the information you need, and the two key things are the snippet name and the actual location in the temporary file. So line 2, column 107. When 12D runs, it creates these temporary files for each snippet, and there's different levels. There's an option there to output passing stages where it'll actually output all the different stages that the snippet goes through to pass through the MTF. If we open that one called broken, we can see the errors in here, and it's telling us to go to line 2, column 107, name position. So if we go into the temp file, we'll find a formula at that location. So line 2, position 107, and we've got a formula here. We go, okay, 0 minus 3, that doesn't really mean much. If we go along a little bit more, we'll find the formula here is actually in brackets. So, okay, something a bit weird. And we go along, and at the end of the line is a comment, and it's just got the number 16. So you're sort of thinking, okay, again, doesn't really explain too much what the number means, but it's just, okay, all these lines have got numbers on the end of them. What that number there is now referring to is the line number in the original snippet where the problem is occurring. So if we open up broken and go to line 16, and we go to where that formula is being created, which is here, and we find, okay, I've got a variable. All right, so I've got a variable. Now this is where things can get a little bit harder. So the error's occurring at line 16, but there's nothing wrong with the variable. So sometimes you actually got to work backwards and figure out what's going on. So working backwards from there, we go back to where start is defined, and we see that there's a formula. And the syntax for the formula is wrong. This thing should have brackets and quotes and everything around it. So we can simply fix that error with some brackets and quotes around it. So we've got start here, we come back up, here's where start's being defined and the formula's wrong. So we simply put some brackets and quotes around it. Save that. Now if we come back to 12D, let's close it. Open it. Alright, and apply. So we've got another error coming up now. So we're now line 3, column 104. So again, we come back into File, refresh that. Next page. Alright, so again, weird looking error, but, you know, 2 pieces of information. We got the name of the snippet and we got the line number. So we go to line 3 and we'll end up with something weird looking like this where we've got name, position, modifier start, link fix. We've actually got a double up. The command is repeating itself, and if we go all the way out to column 104, there's a parameter in there, variable in there called Fred. So okay, we go all the way to the end and we go to line 18 in the actual snippet itself. So we come back to that snippet, we go down to line 18, come across, and there's Fred. Okay, what's Fred? So we go, okay, come back up, and Fred isn't defined anywhere up here. So we're going, okay, there's a typo there. They must have been doing a demo and we've called something Fred. So we have a think about it and we think, okay, yeah, that's should, rather than Fred, that should be start. So we fixed the variable. Correct variable name. Well, the variable name should be length, not start. Let me go back and fix that. Should read my notes before jumping ahead. So fix that. Let me just rerun that. There we go, that's better. Okay, so a slightly different message this time coming up. Alright, so we're not getting our line numbers and everything like that, but we're getting an error message which is pretty much a standard MTF error message that comes up. I'm not sure why people have trouble in deciphering this one, but it's there anyway. So it's basically telling us it's doing something with the left edge line, and name does not exist for inserting before design KLL. So you're going, okay, it's a bit odd. Let's go have a look. We can go into our temp file and we can have a look, okay, where's KLL being used? So we come around through here. That didn't refresh properly. There we go. So we come through here, we're looking for KLL, so modify start. There we are in there, so KLL. So what we can see straight away is we've got KLL there, but these ones are KLR. So we've obviously done something wrong in the snippet. Again, we can just come back on here, line 16 in the snippet. Come here, come back to line 16, and we've left off the auto left right. So we can take him, just replace that. So what was actually happening is, because we'd left off the auto left right, we just had KLL, but we were doing this on the right hand side. So the MTF was looking for a string called KLR, and we were telling it to look for a string KLL, but of course that didn't exist. The string that actually exists is KLR, so L and R for left and right. So we save that one. We should be able to come back now and run him. And all good. And there we go. What you can see coming up down here are these user messages I was talking about before. So these are coming out of the parking bay snippet. So yeah, so sorry, that broken one's all fixed now. So that's simple error checking. These messages coming down here. So you can see here we got the formulas and everything coming out. So that's all stuff that we can, like I was saying before, good messages and error checking and debugging when you're writing a snippet. You can actually see what's going on in the background. So we did all that, left out the parameter, and that's it.
Thank you, Joel. I'll email you the questions from today's presentation shortly. The recording of today's webinar will be available in coming days through the webinars page on our website and on our 12D Model YouTube channel. We'll also email the link to all registrants in the next day or two. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.